Welcome to Making Waves, the podcast where we spotlight real projects at Kleinschmidt and the people who bring them to life. I'm your host, Ben Carey, and in each episode, we go behind the scenes of a project, the challenges, the innovations, and the human stories that bring them to life. Today's guest is Kevin Nebiolo, our senior data scientist at Kleinschmidt, and I'm really excited to talk with Kevin about Emergent, a new agent-based modeling software and program that he has helped develop. And just excited to learn more about that. So let's go ahead and dive in and make some waves. Welcome, Kevin. To start us off, I have to ask you, have you ever been on a podcast before?
I have not. This is my first time. I'd like to thank you for having me.
Absolutely. Are you a podcast listener?
Yeah, definitely podcast listener. My wife loves them. I'm always getting dragged into the newest thing. So yeah.
Very cool. Well, hopefully she'll enjoy listening to you on today's episode. Before we dive into the project, the software is what we're going to be mostly discussing today. I did want to learn just a little bit about you and let people behind the curtain. So tell us a little bit about your role at Kleinschmidt and how you ended up working in the hydropower industry.
Yeah. So I wear a few hats here at Kleinschmidt. I'm a section manager. I've got a ragtag group of GIS professionals, statisticians, database managers, and data scientists working for me. I'm also a technical advisor in the firm and a senior data scientist in my day-to-day. Believe it or not, though, I actually started as a fish biologist, working hands-on with endangered species like short-nosed sturgeon. But along the way, my background in GIS and data management became more central, and it soon became pretty clear that I was my biggest impact was going to be behind a computer rather than out hip deep in rivers. So that led me to grad school, and where I got a deeper understanding of programming, spatial analysis, modeling, and then eventually machine learning and AI. Believe it or not, I gave an internal talk way back in 2012 here at Kleinschmidt about Python and machine learning. And fast forward to today, those ideas are mature enough, I think, that it's going to allow us to reshape how we design and evaluate hydropower infrastructure. So I'm very, very excited for the second half of my career here.
It seems like your role, compared to many of them at Kleinschmidt, is one that's like changing rapidly, maybe even year over year in terms of like how a data scientist is integrated into hydropower work.
So fast, and it's only picking up steam exponentially. The pace at which the development tools coming online is just breathtaking. So it's an interesting spot to be for sure.
Yeah, yeah, very good. What would you say is the part of your job at Kleinschmidt that you enjoy the most?
Oh wow, part of my job I enjoy the most. Oh, if you asked me this 20 years ago when I first started, it would be sitting on the front of a boat watching the world go by. But now, as a section manager, before my role as technical advisor, I was also a discipline leader. So I got the chance to mentor. And over time, I started to get much more satisfaction out of seeing those that I mentored succeed versus benefits for myself. Is honestly, that is probably the best part of my job is seeing the people that I oversee and that I've mentored along the way become successful professionals.
That's awesome. It's great to hear, and I can vouch for the fact that you lead a great team, and I'm sure that they all appreciate your leadership role in that. Let's transition to some rapid fire questions here, a few
Sure.
icebreakers here. So, if I could offer you the opportunity to work in a comfy office chair or in field boots for the day, which one are you choosing?
Is it a nice day outside?
Unknown.
Oh, the old roll of the dice. I don't. It's honestly, it's been close to a decade since I've been out to the field, so maybe I want one or two of those days again in my life. Maybe I could do that now with the team I've got under me.
Fair enough. Fair enough. All right. What about coffee before work or a cold beverage after?
Coffee before or cold beverage after? Both.
If you had to choose one, though.
Oh, I had to choose one. Yeah. I think it would have to be coffee. I don't think I can live without that.
I think we're 3 for 3 on that side of the question so far in these episodes. So you can tell we work in the engineering and science world. What about, would you rather live without electricity or live without shoes?
If I choose live without shoes, I'm moving to Hawaii and I could best live without shoes. How about that?
Yeah, okay, I like that. That's a good qualifier there on that one. And then last one, based on the conversation we were having before this call, I might know the answer here, but cats or dogs?
Dogs. I've currently got one on my lap.
Yeah, yeah, good stuff. All right, let's transition to talking about the project that we're going to be talking about
Sure.
today. So, give us the big picture. What is Emergent?
Yeah. Emergent and agent-based modeling really is a way to simulate systems of interest from the bottom up. So instead of trying to find the average fish behavior, your central limit theorem way to look at the world, we model individual fish as autonomous agents that follow a simple behavioral rule set. So things like orienting into the flow, avoiding collisions, resting when fatigued, and moving towards a refuge when they are fatigued is built into the model. And those simple behaviors, as it turns out, leads to a phenomenon called emergence, hence the name of the software. And that's really what happens when you let thousands of those individuals interact. You start seeing realistic passage routes. You start seeing delays, schooling behavior, and bottlenecks just forming. And these patterns were never explicitly coded. I did not tell the agents to delay there. It just happened. And so that idea is that complex management relevant behavior emerges from these simple rules that we apply at the individual level.
Gotcha. And I guess what was the origin of the idea of developing this? What was, I guess, the need case for this software?
Oof. The origin of my idea with it or the project?
Either or.
Yeah, the project. Let's do that. Let's do that. This was a FERC licensing project. The proponent was a small rural cooperative who currently depends upon diesel fuel for electrical generation. This is up in the wilds in Alaska. And they are looking at developing a diversion with a tiny powerhouse that is able to produce all, if not more, of their electrical generation needs. And this is important for the changing climate as well as their long term prospects. The village still wants people to live there, but it's getting more and more expensive to ship that diesel over. So they had to now perform this study, a fish passage study, because this cooperative, if they get their license and develop the project, would be ciphering off, I'd say, about 30% of the flow. And of course, that would change hydraulics over the falls, and it would change how the population of fish would then move through those falls. Hopefully, this project is not going to have an impact on the population, and the population still remains sustainable. So you would still get the same amount of fish now going through less water, right? If you would incur too much delay, then that could affect spawning success. And then that's not good for the underlying population.
Yeah. And besides the data science side of this, which I'm sure it's very heavy, were there other kind of like key technical partners that were part of the development of this?
Yes. Yeah. So you really can't have a model like this if you don't also model the environment. And so for that, I'm going to need a hydraulic model. And I'm not an H&H professional, but luckily at Kleinschmidt, I am surrounded by a team of amazing H&H professionals, and they were able to produce the model, a very fine scale, highly accurate, highly precise model that we used then to represent our individual fish agents' environment. And they lived and essentially, they lived within that HEC-RAS model your team was able to create for me.
Yeah, very cool. Now, let's transition to talking about challenges. Every project has its challenge, and I'm sure when it comes to building a program like this, there were many. What were some of the biggest ones that you faced?
Oh, yeah. We had a few. I'd say the first one was that we wanted realistic movement and energetics without building a full rigid body hydrodynamics model, which would be computationally impractical because we would have to solve the full rigid body dynamics as well as the underlying hydraulic model and behavioral model. So we just don't have the computers for that. So we settled on the loosely coupled model that we have now, where the flow affects the fish, but the fish doesn't affect the flow. And the model is lightweight enough that I could place it on top of any 2D HEC-RAS model of any system. And next up for development is being able to take the model and essentially put it over the output of a CFD model to get realistic three-dimensional movement and behavior. So another challenge was behavioral realism. So making sure that schooling, sensing fatigue, and memory all interacted in a way that was produced a believable movement, not just fancy animations. But the biggest challenge over all of that, though, was optimization. So once that behavioral framework was in place, it became clear that the realism at the school level comes with a serious computational cost. I actually spent close to 2 years, believe it or not, focused my development focusing entirely on performance, learning, experimenting, and also iterating with AI assisted coding tools to make the software as efficient as I could. So we started by refactoring everything into modern array based processing. And then we finally got our hands on a high power GPU here at Kleinschmidt. And we updated the software. It started to use CUDA processing through a software package called Numba. And that transition fundamentally changed what was feasible. Suddenly, we could now simulate tens of thousands of interacting agents, all complex behavior, energy budgets, and as well as spatial memory in near real time. So it really just wasn't about the code making faster. It actually now expands upon the scientific questions we can ask. We could we could simulate realistic size schools now, which is amazing. I didn't think I was gonna be here 3 years ago, that's for sure.
Now, without that technological breakthrough that you just described, do you think that this developing this would have been possible, or would it just been a lot slower? What would the outcome have been there without that breakthrough?
Yeah, so it's entirely possible. Once I got to the array-based processing, it was still processing on my CPU. So that allowed me to have all of the realistic behaviors that I wanted. And we were able to actually do production runs for the report at that model state. So this was kind of year 2 into the project. So we had done some optimization, and I think for the model, we had to run 8-hour simulations in real time, and we had to have at least 1,000 agents, and it would take 17 to 18 hours per model run, and we had to run hundreds for that report. So that took a while, and it became apparent that if we wanted to model anything of consequence, like these large schools, which are actually present and actually there, we were going to need something more heavy duty, and we finally got it. And now it's scary. Buckle up. We could do some cool stuff.
Yeah. I'm going to throw you a curveball here. So, in listening to you describe this, what immediately comes to mind is that this sounds like a research project at a university. And I'm sure that there would have been some advantages of being able to do this in a more academic setting versus project setting. But I'm sure there was also advantages of having a real project with a real budget that you could use as a test case. What's your perspective on whether the project would have been easier or harder had it been done in a more of an academic setting?
I think it would have been more difficult for sure, only because it touches on so many different domains. In academia, especially in graduate school, they put it all on you to get something done unless you happen to be working in, excuse me, in a lab with other scientists and you are all working on the same problem. But in the graduate program that I was involved in, you were expected to do it all. So that would have meant that I would have had to do the modeling, the two-dimensional hydraulic modeling on top of all of the behavioral modeling. And I'm not a hydraulic engineer. I would have had to take multiple courses and completely change the way I did my graduate work. But because I didn't do that, I was able to really focus on agent-based modeling and the what was possible with that type of modeling framework.
Yeah. Yeah, I think it highlights one of the really cool things about Kleinschmidt, both working here and I'm sure clients feel this on the client side of things, and that is just the collective brain power in so many different technical areas that can come together in a lot of different ways on different projects and use that collective knowledge to tackle just widely different projects. This being kind of one of the more extreme ones in terms of
Yeah.
technological advancement and development and whatnot, but a really cool example of that. Anyway, it sounds like it was a real team effort. So let's talk about a little bit more about the people behind it. I guess what, from your perspective, what made this project special from the people perspective?
Oh, what really stood out to me was the commitment and grit that my team gave to me, especially during those final production runs. I think we touched on it. Each run took 17 to 18 hours each, and we had to run multiple iterations per discharge scenario, and we had, I think, 10 or 12 different discharge scenarios. So you're talking potentially hundreds of models, and at that time, we didn't have the luxury of a GPU, and we hadn't yet completed some of the other major optimization work. So that meant that what we had was extremely compute intensive. So even though we still had those barriers, the team pulled together and they still executed the required runs. And that takes a lot of patience, takes a lot of coordination, and a lot of belief in the value of that work. So they understood what we were building and why it mattered. And they showed up and they performed the unglamorous, grinded out phase that usually gets overlooked because, well, everyone always wants to see the pretty video at the end. That effort is absolutely essential to delivering real science. And we could not have finished that project without their effort.
Yeah, that's really cool. We've talked a lot about kind of the internal side of this project and all the work and effort and brain power that went into developing it and the application that was designed to address. Let's flip and talk about the people on the receiving end of this. How did, the general public or the stakeholders that these results were presented to receive this?
Yeah. At first, there was some trepidation by the agencies. It was a new approach that had never, well, not necessarily had never, but it was very rare to apply this type of modeling. It had only been really done on major river systems in the United States. at very large infrastructure projects. And so we applied a new modeling framework here, as well as being one of the first, if not the first, to incorporate schooling dynamics into the modeling approach. We had to sell the approach to the agencies on the ground as well as your NGOs and meetings. And I think what was the most helpful really was to see the side by side comparison with drone images. We were out there with one of our drones taking video, snapping photos, and really understanding where the fish migrated, what side of the river they were on, where areas where there was refuge and they were recovering from energy use. And when the agencies and every one of the public meetings saw the results side by side, it was it was surprising all around of how good that actually was. And so that went a long way in selling the approach. Of course, there's still detractors who are concerned that the approach is new. I think with this generally accepted effort as well as future efforts, you're going to be seeing a lot more of this type of modeling at all sorts of fish passage projects, not just dewatering of falls like we're doing now. It could be understanding schooling dynamics in front of a fish passage entrance, for example.
Yeah. This question just popped in my head. It's a little bit off topic that we're talking about right now, but I do want to ask it. And that is, obviously, this project started a number of years ago, and
Mhm.
we've both, you and I collectively, understand the amazing rapid change in, or the proliferation of large language models in AI in our work, in our fields. Do you feel like if this project was starting right now, it would have been done differently, faster, or do you feel like we were on the cutting edge of using some of those tools at our disposal?
Yeah, no, if we had the tools we have available right now, it would have been completed much faster. And that just goes to show you how fast the AI landscape is moving. So I finished the proof of concept for that in 2023. I didn't actually use an AI to assist me during that. It was just the old fashioned going on Google and Stack Overflow and the forums and trying to get your code to work. But the coding tools that were available to us at that point in time were getting pretty good and sophisticated, and they were starting to get at parity of where my skills were. So I started to rely and utilize these tools to help me. And now the tools that we have at our disposal are just so incredibly powerful. And based upon what I know from not only Emergent, but every other of my repos that have retouched with AI, I've gone in and essentially updated every single one of my projects. And I've got a bunch of projects on my GitHub, and AI now has touched everything. And it's just make it faster, make it better, add more tests, do more validation work, update documentation, you name it. It's being used to just improve and update and create now. And there was one point in time when I was just getting into what's called vibe coding. And I said, okay, I've touched pretty much most of my repos. I built some scripts. I want to build a complete piece of software from the ground up. And I did that. It took me 5 nights, and I created a full 3D simulation model of three-dimensional schooling, and I actually had a simulated fish passage entrance there. And I pretty much got this whole idea going in 5 nights, and it just revolutionizes everything that we do. My job is completely automated. Looking forward, I don't think I'm ever going to write code again. You don't have to. The soft skills are going to become important. Your creativity and your emotional intelligence is going to become a lot more important than what you know and how much.
Yeah.
So it's going to change things for sure.
Yeah. Yeah. We don't, obviously, we could probably do an entire episode on more of an AI and hydropower conversation. I don't want to get into that today, at least. Maybe we can come back to that at some point. But I do think that this project seems like a good example of a positive application of that,
Mhm.
of large language models. And what I mean by that is you built and struggled through developing an understanding of how to do this without the direct influence of some of those tools. And now, if you had access to them, it would simply supercharge your progress as opposed to
Yeah.
just doing it for you yourself. And it feels like that, at least in the hydro world, is the perfect application where you could do it yourself. You started or maybe even made some really good progress, but then you're just able to supercharge that and make it more efficient and faster.
Absolutely. Absolutely. That is 2026 is going to be about breathtaking progress
Yeah.
for
Yeah.
sure.
Is there a single moment or story from that project that kind of sticks with you to today, or was it more just accumulation of effort?
Accumulation of effort for sure. But I think the most satisfying thing for me was, again, seeing the output side by side with the drone imagery and the drone video. Uh, to see my agents uh, circle back and forth behind a rock because they're recovering after going over a falls, and to see one of the drone pictures of that same rock with a number of fish in the leeward side of that, downstream of the flow, right? So that the rock was giving them shelter, and they were there, they were recovering. To actually see that was just unreal. So that was probably the most satisfying thing. The most thing that struck out the most was the biological realism that we got out of this was just astonishing.
That's awesome. What lessons would you say working on this software and this project taught you that others in the industry you think could learn from?
Mm. I think that if you oversimplify behavior, you're especially people who do this type of agent-based modeling, that your predictions won't be just a little bit wrong. They can miss a system entirely. So fish passage is often treated as an individual, and it's a hydraulics dominated problem, right? We designed fish passage for the individual within their range of tolerances. But in reality, fish passage is a collective behavior driven system. And once we start accounting for schooling or things like schooling, sensing their ability to sense fatigue, their spatial memory, the system stops behaving nicely, right? It stops e- behaving as expected because you had a deterministic set of functions, right?
Mm,
And it's now chaotic. But that's actually when it becomes more realistic and you get a full understanding of actually what's going on rather than just the average fish behavior. So I think another key lesson is that complexity isn't the enemy. Unacknowledged complexity is. Systems that look chaotic are not actually random. They're structured with simple behavioral rules. They're very simple rules governing how these fish move upstream, yet we get incredibly complex behavior that we don't actually code. I don't code for fish to form schools. They just do it based upon their instincts. And then you get behavior that you can't code for. There, there is no control over the agents once you press go on the simulation. So really this modeling is these models let us embrace the chaos instead of smoothing it away. And so I really do think that you could get a deeper understanding of what's going on inside your fish passage device this way.
Yeah, that's a perfect answer. Last question here for you, or I guess last topic. And I think I know the answer to this, but looking forward, do you feel like this software can be applied to other locations and projects that Kleinschmidt works on? And if so, why would you say a client should consider hiring Kleinschmidt to use this technology for them?
Yeah. So that's one of the mm, that's one of the things we had in mind when we were developing this. The software is written with the thought of applying it at different species and regions, right? So we could take it and we could put it on top of any HEC-RAS model, or we could put it on top of any CFD model of any location. And all the underlying models and functions that control behavior and movement came from the literature. And though all the parameters for those models have been fit to particular species of interest, right? So the hard part going forward is getting behavioral data to calibrate some of those parameters. But you could do that with, say, existing telemetry data sets or from the literature. So that I think is the biggest impediment to really applying this in different locations is collecting that underlying information because it is rather expensive to do that. But if you say fit a model to American shad in a large river system out here on the East Coast, but then one of our clients in a smaller river was doing a study with American shad. If you had a validated model, if you were able to statistically validate that model and say this produces behavior that matches real world behavior, there's nothing stopping you from using the model parameters in one system for that particular species and applying it in another system. But different species, I would worry about calibration data. With different systems, that really isn't a problem at all as long as there's an underlying hydraulic model.
Yeah. And that was going to be my follow up, and maybe more of a question for a fish biologist, but just curious whether it, there is evidence that it can be applied across systems for similar or for the same species, because I would imagine there are some behavioral differences from system to system in certain species, and maybe certain species there's not, and the behaviors are virtually the same across. So I'm not sure if that conversation came up at all, or if you have an opinion on, I guess, the cross system application for the same species in the same region of the country.
Yeah, so that comes up there. You have like Chinook, for example. There's fall Chinook and spring Chinook, right? And there's behavioral differences between them. So there is an element of understanding the underlying biology, and that's why having an interdisciplinary team is critical. I left the fish biology on the side a long time ago, and I got really good at numbers and computation. Well, if I didn't have a fish biologist looking over my shoulder, looking at the model results, understanding the parameters that we were putting into all these models, the project would have gone off the rails re- really quickly. But I had that senior expertise stating, "Oh, why are you using that model? You should read this paper and use this instead." Without that, it would have been very hard to have a successful project.
Perfect. Kevin, thank you so much for sharing the story behind the agent-based modeling software Emergent and the work that your team both did and are actively doing. Before we close out, any closing thoughts for the people?
For the people, oh man, this is really hard. Yeah, just from my agent-based software work, just embrace the chaos, folks.
I like that. I think that's a motto for baseball as well. And we're getting started here with baseball season. So embrace the
Yeah,
chaos,
great
whether you're
chaos.
playing baseball or running agent-based models. Like,
Oh,
good
yeah,
advice. Yeah.
for sure.
All right, awesome. Thank you to everybody who tuned in today to Making Waves. If you enjoyed this episode, be sure to subscribe and share it with a colleague, a client, or a friend. Join us next time as we continue to highlight the projects and the people that make Kleinschmidt so special. Thanks, everybody, and thanks again, Kevin.
All righty. Have a good one.